This is problem 9, integral of dx over root square 8 minus x squared. In this first step, we need to find which formula from as integrals formulas can solve our integral. And in fact, we have this formula integral of du over root square 1 minus u square equal arc sine of u is very similar to our integral. However, in our integral we have 8 minus x squared, and in the formula we have 1 minus u squared. So we need to convert between those two expressions. And I will do this by taking 8 out from 8 minus x squared, which will give me 8 times 1 minus x over root square 8 square. If we adopt x over root square 8 as variable substitution, u, we will get at the end 1 minus u square. So u will be equal x over root square 8, but root square 8 is equal to root square 2, and I will explain in a moment why. So finally u will be x over 2 root square 2. And just to explain why, 8 is equal 2 square times 2. So if you root square 8, you will get 2 root square 2. Now that we have determined the substitution we are gonna adopt, u equal x over 2 root square 2, we are gonna apply that substitution into the integral I, so we convert it to a function in terms of u, I of u. First, let us compute dx. So dx would be 2 root square 2 times du. Next, we will complete the integral I of u, which will be equal to integral of 2 root square 2 du over root square of 8 minus x squared, which is, by the way, 4 times 2 x squared, which is 8 u squared. We can simplify this integral even further, but first let me explain just on the side that x squared is equal 4 times 2u squared. That's why it is 8u squared. Now let's simplify further that integral. That integral could be written as integral of 2 root square 2 du and in the denominator we can take out root square 8 or otherwise 2 root square 2, because root square 8 is equal to root square 2, as explained before. So in the denominator I will take 2 root square 2 out, and that will multiply root square 1 minus u square. And we can simplify 2 root square 2 up and down, and we will get the final integral. Now that we have an integral that's easy to apply the formula to, we will apply that formula that will give us arc sine, and so I would become equal to simply arc sine of u plus the constant c. So arc sine of u plus the constant c. One last step is to convert the integral I, which is now in terms of u, to convert its variable u to x, because we want the final answer to be ix and not iu. So we will be using the substitution u equal x over 2 root square 2, and that equation will allow us to make the back substitution directly. So I would become arc sine of x over 2 root square 2 plus the constant c.